I hope you are all aware of that. In this month, IIT JAM examination was conducted, and most of our students said that questions were very tough. So I was not able to give the proper answer, and I don't have the hope on this IIT JAM examination. So when I was looking at the questions, yes, the questions were really tough. Some questions were little bit easy, but most of the questions were very tough. And I have decided to give a solution video on this topic. So in this video, I'm going to discuss IIT JAM examination, organic chemistry questions. This is Dr. MK, and welcome back to our channel. The first question is the molecular structure of table sugar is. Table sugar is nothing but sucrose, and you need to find out the structure of sucrose. I used to give advice to my students that don't follow the sucrose structure whatever given in the normal textbooks. And Advanced Organic Chemistry by Baldner and Ball. In that book only, the proper way of structure of sucrose is given. So just try to follow that. Now I'm writing the structure of sucrose here. So this is a structure of sucrose, as this part of sucrose contains alpha D glucose and beta D fructose. Right. So now you need to correlate this structure with these options that they have given here. And you can look at here, in the first structure, you have the glycosidic linkage here. So between this glucose and fructose. And in this case, below the plane, you have CS2OH. So here also you have below the plane CS2OH. And next to OH up, next to OH down, and next to CS2OH up. So OH up, OH down, CS2OH up. Okay, fine. So this part is fine. So next one is, if you have to look at here, that is in this case, that is in alpha D glucose case, you can look at here. So here you have OH down, OH up, OH down, and CS2OH up. So here you can look at here, OH down, this OH is up, this OH is down, and this CS2OH is up. So the first option A is matching with this sucrose structure. So right answer is option A. Next question. The product formed when R2-bromopropionic acid is treated with a low concentration of hydroxide ion. The resulting product, the configuration will be. Let me write the structure here. This is a well-known question, and I have taught my students also this question, and I said this question is important. If you happen to look at the configuration here, this is 1, 2, 3, so clockwise direction arranged. So this is having R configuration. This is called as R2-bromopropionic acid. Now this molecule is treated with low concentration of hydroxide ion. For example, you can use sodium hydroxide or potassium hydroxide. You know that sodium hydroxide or potassium hydroxide is a base. Base initially reacts with acidic hydrogen. It takes the carboxylic acid proton and it is removed as water molecule to form the corresponding carboxylate ion. So there is a leaving group here, and here you have a negative charge containing atom. Immediately neighboring group participation will take place. The leaving group is present front side to the plane, so attack will take place from the back side to the plane. So as a result, bromide ion will be leaving and leading to formation of an intermediate like this. So here you have methyl group. Now one more mole of hydroxide ion will be coming and attacking here. So this is a leaving group. The ester group is a leaving group. The leaving group is present backside to the plane. So the incoming nucleophile should approach from the front side to the plane. So that means if it is approaching from here, so the electron is shifting over here, and this leads to the formation of a product. And after protonation, O minus becomes OH. Now, if you ever look at the product configuration, this is 1, 2, 3. So 1, 2, 3 is arranged in clockwise direction. The product jump in, that is configuration is R. So that means the reactant is also R configuration. Product is also R configuration. So that means the retention configuration is taking place. The right answer is option B. You may ask a question. If it is high concentration, then what will be the product, sir? That is high concentration. So directly what happens, the OH minus will approach this chiral center and leading to the formation of inversion product. If you have low concentration means that is retention of configuration. Next question is Wilkinson catalyst contains. I think this is one of the easiest questions that they have asked. You know the formula of Wilkinson catalyst? And the central metal atom is rhodium. What is the geometry of this complex that they have asked? That means the structure will be a square planar. Very simple question. So that is rhodium, which is having +1 oxidation state, which is in square planar geometry. Option C is the right answer. Next question, the major part of the following reaction is, you know that recently I have made a video on bare vinegar oxidation, and in that case I have explained the migratory aptitude and all, and I give the link in the description section. If you want, you can follow those videos. And if you follow my video, you can come to a conclusion that the migrating aptitude, and if you happen to look at here, so this is a secondary center, this is a primary center. You know that which is a better migratory group. Obviously secondary carbon atom is a better migratory group in bare vinegar oxidation. So what you need to do is just insert an oxygen atom between the secondary carbon atom and the carbonyl carbon atom. That's it, over. And if you happen to do like that, you are going to get a lactone like this. This is the first step. Now this lactone is treated with lithium aluminium hydride. You know that lactone is cyclic ester. When you treat an ester with lithium aluminum hydride, initially you will get aldehyde and an alcohol, and the aldehyde is further reduced. Since lithium aluminum hydride is a strong reducing agent, it will be reduced into a primary alcohol. I hope you know this reaction. So that is what they have asked. And if you do that reaction here, so this is a lactone, that is cyclic ester. So this is reduced into alcohol and aldehyde. this aldehyde is further reduced into primary alcohol. Fine. Now what you need to do is you need to look at this part alone. So this is a 5-member ring. This is a 5-member ring. Draw a 5-member ring here. And you need to give the stereochemistry of the product. That is what the important thing is. What you need to do is just rotate this molecule like this way. Just tilt the molecule in this anti-clockwise direction, and this ether part will go below the plane. Correct? Now, if you do the rotation towards anti-clockwise direction, and this OH and this CS2OH will come above the plane. Able to understand now? Just do the rotation like this way, and you can get the OH group above the plane, and CS2OH group also will present above the plane. And if you happen to look at this structure, this is matching with that is option D. We'll go to the next question. The major product P and Q of the following transformations are. This is an elimination reaction. You know that during elimination, especially E2 elimination case, the incoming group and leaving group should be antiperiplanar. If it is a cyclohexane case, you can directly give trans-diaxial. And having this idea in our mind, let us solve this question. So you need to draw this structure 1 into the corresponding chair form. So this tertiary butyl group should be in equatorial position. A bromine should be occupying axial position, and this COH group will be occupying equatorial position. So when it is treated with the base, say for example any base, say for example alkoxide will be a suitable base in this type of reactions, and this is a leaving group. This is a leaving group, and this leaving group is present axial position. So you need to look at the beta hydrogen. Incoming group should be present at beta position. So this is a beta hydrogen. Here you have trans-diaxial between the incoming group as well as leaving group hydrogen is present. Here also there is a trans-diaxial kind of incoming group, leaving group are present. Now you need to find out which will be more reactive. You know that this COH group is an electron withdrawing group, and this hydrogen which is closer to COH group will be more acidic. What happens here? The base takes this acidic proton and the electron is shifting over here, and Br minus will be leaving. And you are going to get an alkene. If you redraw the structure, you are going to get like this. So this is the structure of compound P. Now let us solve this second case. In this case, the CO2H, that is a carboxylic acid, is present axial position, and bromine also occupies axial position. That means these two are trans-diaxial with each other. So what happens initially when you treat with a base, the base takes this acidic hydrogen and it gets deprotonated. And in the case 1 also, first reaction also, the deprotonation of carboxylic acid will happen. But that carboxylic acid group is present at equatorial position, so we are not going to consider that one actually. So that is why directly we are looking at the axial hydrogen, and it underwent elimination process. So now what happens, this carboxylate unit and the broma group, which are trans diaxial to each other, what happens here, the electron will shift over here and this will be shifting here and Br minus will be leaving. So the bromide will be leaving, along with that carbon dioxide molecule will be leaving, and it leads to the formation of an alkene. If you redraw the structure, it is going to be like this. This is a structure of compound Q. And if you have to look at these two structures, that is, this is a structure of P and this is a structure of Q, the right answer is option D. Next question, the correct order of the rate of mononitration using concentrated nitric acid and concentrated sulfuric acid at room temperature is. Yeah, this is a simple aromatic electrophilic substitution reactivity order. You know the basic things, that is electron donating group attached benzene ring will undergo aromatic electrophilic substitution reaction faster than electron withdrawing group containing benzene. If you happen to look at this rule and you are going to apply this rule with these options, and let us take any one of the options. In the first case, that is, this is known as anisole, the methoxy group having two properties, that is, it is having minus I and plus R. Among these two effects, the plus R effect will be dominating, and it is considered to be an electron donating group. Right. And in halogen, that is fluorine, chlorine, or bromine. So all the three cases, you can say that there are two kind of electronic effect. One will be minus I, another one is plus R. And among these two, minus A effect will be dominating. And here also minus A effect will be dominating. And here you have no electron donating group and no electron withdrawing group. So that means you need to find out the group that is the electron donating group which is attached to the benzene ring will be the most reactive. If you happen to look at here, that is anisole will be more reactive. So you can look at option A or option B. And if you happen to look at the next molecule in option A, that is a fluorobenzene is given. You know that fluorobenzene is having minus A effect domination will be there because of fluorine atom. So it is generally considered to be an electron withdrawing group. Here also it is considered as electron withdrawing group. And in the case of benzene, there is no electron donating group as well as no withdrawing group. So that is better reactive than fluorobenzene. So the second one is the right answer. It should be the right answer. And the first one is anisole is the most reactive, and second one is benzene, and third one is fluorobenzene, as well as then you have bromobenzene. You may ask a question, sir, fluorine is more electronegative than bromine, then why fluorobenzene is more reactive than bromobenzene? Means you know that fluorine outermost electronic configuration is 2s2 2p5. So here in bromine, that is 4s2 4p5. Carbon's outermost electron, that is orbital, is that is electronic configuration is 2s2 2p2. Here also 2s2 2p2. So that the principal quantum number is 2, and for fluorine also principal quantum number is 2. And here you have carbon principal quantum number is 2, and bromine principal quantum number is 4. And you know that even though fluorine is having minus effect, it also having plus R effect because of the presence of lone pair of electron on fluorine atom as well as bromine atom, and which will be giving the electron towards benzene to make the effective overlap. You know that in fluorobenzene, the carbon principal quantum number and fluorine principal quantum number are same. So effective overlap will be there. So electron transfer, that is a resonance, will be taking place more readily than bromobenzene. For example, in bromobenzene, the principal quantum number are differing. So that means the effective overlap between carbon and bromine will not take place. So the electron transfer to benzene through resonance effect will not take place that easily. So it will be less reactive in nature. So the right answer is option B. Next question. Pericyclic reaction involved in the synthesis of vitamin D12 ergosterol. I don't know for BSc pericyclic electrocyclic reaction is there in the syllabus or not. I don't know, but I used to teach my students. I don't know whether they have given the right answer or not, but now I will give the answer to you. And for our convenience, I'm just drawing this part alone because here only the reaction is taking place. Right. Initially, what happens here, this is a cyclohexadiene system, so it can undergo 4n plus 2. Electrocyclic ring opening reaction. There is a methyl group here. So here 6 pi electrons are involving. So this is an electrocyclic ring opening reaction. I'm not going to explain the con rotation, this rotation here. And next step, what happens here? So there are 3 hydrogen atoms present in the methyl group. So out of 3 hydrogen, 1 hydrogen will be involving in rearrangement. So this hydrogen electron is shifting here, this is shifting here, and this is shifting here, and the carbon atom making a bond with this hydrogen atom. There is CS2. There will be a double bond here, double bond here. That's it. Hydrogen will be migrating towards here. So that is a rearrangement taking place. And this carbon hydrogen bond is broken here. So this is 1 and this is 1, 2, 3, 4, 5, 6, 7. So there is a new bond formation between the hydrogen 1 and the carbon 7. So this is said to be 1, 7 sigmatropic hydrogen shift. So in the first case, that is 4n plus 2, otherwise 6 pi electrocyclic ring opening reaction. The second step, that is 1,7 sigmatropic hydrogen shift is taking place. If you combine these two reactions together, the right answer will be option, I think option A is the right answer. Right. We'll go to the next question. The major product formed in the following reaction sequences. Again, it is an interesting question. You know that is a benzoin condensation. Benzoin condensation. Two moles of benzaldehyde is treated with ethanolic KCN and it will be converted into benzoin. Exactly the same reaction is happening here. Let me draw the structure of this biphenyl. You have an aldehyde group over here. There is one more aldehyde here. Initially, a Cn minus attacks here, and the electron is shifting over oxygen atom. So O minus takes this acidic hydrogen, the electron is shifting towards carbon atom. It leads to the formation of carbon in intermediate. This carbanion attacks here, leading to the formation of a cyclic compound. That is an intramolecular benzoin condensation. So it takes the acidic hydrogen and the electron will shift over here and Cn will be leaving. Leading to the formation of a cyclic benzoin. So OH is here and C double bond over here. So this is the first step. The second step, this molecule is treated with dilute nitric acid. You know that nitric acid is an oxidizing agent. So it will oxidize the alcohol into the corresponding ketone. And it leads to the formation of a diketone. So when a diketone, 1,2-diketone is treated with aqueous KOH or aqueous NaOH, and this reaction is called as benzyl benzylic acid rearrangement. I don't have space here. If you can get it from internet also, this basic reaction. And if you apply this reaction here, you are going to get a cyclic. There is 5-member ring which is having carboxylic acid. That is cyclopentane carboxylic acid derivative. And here you have one OH group. That is mandatory. That's a product. If I were to look at this option, that is, I think option A is the right answer to the question. Next question, an organic compound P having the molecular formula C8H16 produces a meso compound upon oxidation with osmium tetroxide and N-methyl morpholine N-oxide. The product P is. Okay. So you know when you can say a molecule meso, a compound which has a plane of symmetry. A compound which has plane of symmetry can exhibit the meso property. And among these four alkenes, initially you need to look at which alkene is symmetrical. The first molecule is, that is 4-octene. Just forget about the geometry of the alkene. Just draw the structure of 4-octene. One, two, three, four, five, six, seven, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this molecule is symmetry. Yeah, it can be possible. It can produce a symmetry product. So reactant, if it is symmetry, means product also will be a symmetrical molecule. And similarly, 4-octene, here also there is a possibility. But 3-octene, if you have to look at this structure of 3-octene, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So this molecule is unsymmetrical. So with this, we can rule out option C and option D because both contains 3-octane as a reactant. And among A and B, which is the right answer? I'll give a shortcut. If it is E alkene, during dihydroxylation, and you will get enantiomers as a product. Enantiomers otherwise can be called as DL pair. If you have Z alkene, that is cis alkene, during dihydroxylation process, you are going to get meso, otherwise called as identical or homomer product. If you apply this concept here, so this octane, that is which is having trans geometry, will be able to give a product meso. Right answer is option B. Next question, the correct order of dipole moment among the following is, again, this is little tricky question. I will give the data here. The right answer is option C. The chloromethane dipole moment is 1.9 D. For fluoromethane, there is about 1.8. For methanol, that is 1.7, and for dimethyl ether is around 1.1. So with that data, you can give the right answer. That is option C. There is an explanation will be there, but we don't have much time to explain here. So you can look at from basic level textbook, you can get the answer. Next question. The major product P and Q for the following reactions are, right? The first reaction involves the reaction of a cyclohexanone, that is 2-methyl cyclohexanone, with this lithium diisopropyl amide. So this is otherwise called as LDA. You know that LDA, that is lithium diisopropyl amide, LDA is a bulky base. The reaction is taking place under minus 78 degrees Celsius. This is a bulky base. It takes the less hindered acidic hydrogen. So this is an electron withdrawing group. Here also there is an acidic hydrogen. Here also there is an acidic hydrogen. Among these two, which is less hindered. So this right side hydrogen is less hindered in nature. So it takes this less hindered acidic hydrogen. And as a result, the electron is shifting over here, and this electron is shifting towards oxygen atom to form the corresponding enolate. And this species, when it is reacting with benzyl bromide, there is an alkylation at the less hindered position. There can be other explanation also. Since the reaction is taking place at minus 78 degrees Celsius, so there is a kinetic intermediate, kinetic controlled enolate will be formed. That is, less hindered enolate will be formed. And in the second case, cyclopentanone, 2-methyl cyclopentanone is treated as sodium hydride. This is also a base. So there is no information about the temperature. So this will be taking this hydrogen only, because if this hydrogen is removed, there will be a formation of thermodynamically controlled enolate formation. Correct. So this will be formed when this is reacting with benzyl bromide. The electron will shift over here, so this will be attacking here, and Br minus will be leaving, which leads to the formation of a product like this. And this is compound P, and this is compound Q. And if you look at the option, that is the right answer is option B to the question. Remember, if the temperature is given minus 78 degrees Celsius means kinetically controlled intermediate will be formed. That is, less substituted enolate will be formed. And if temperature is room temperature means that is the reaction will undergo via the formation of thermodynamically controlled intermediate. That means more substituted enolate will be formed. Next question. The products of the following reactions are, okay, again this is an interesting question. Initially the Cn minus will attack the C double bond O, and after protonation it will form the corresponding cyanohydrine. When a cyano group is treated with lithium aluminum, it will be converted into the corresponding primary amine. Now, when it is treated with the sodium nitrate along with hydrochloric acid, that is diazotization will take place. Now, this is an example of Demjanov rearrangement. Well known Tifonov-Demjanov rearrangement. What happens here when the electron is coming here, so this carbon-carbon single bond can undergo migration, or this carbon-carbon single bond can undergo migration. There are two kind of product formation. And let me draw the rough structures here. So they have asked, this is a multiple choice questions, that is multiple correct option question. CS2, C double bond O, CS2OH, sorry, CS2, and the ring will be there. So this can be one option. The other option can be, if this is undergoing migration, this part is undergoing migration means already one CS2 group is is here, one more CS2 group will be added. Yeah, if you look at these two options, that is option, I think option 3 and option 4 are the right answer. C and D are right. Next question. The set in which all the compounds yield Achiral product upon treatment with methyl magnesium bromide in ether followed by hydrolysis with the dilute mineral acetate. Okay. The first compound, that is 3,4 epoxy hexane. So this is 3,4 epoxy hexane. and this molecule is treated with, assume this molecule is reacting with methyl magnesium bromide. So this is a symmetrical epoxide. At any part the attack can take place. So there is a formation of chiral center here. The question is, you should get achiral product. So this option is ruled out. Then option B. Let us discuss option B. The first reaction, that is ethyl propionate. When this molecule is reacting with methyl magnesium bromide, so it attacks here, the ethoxide will be leaving. So initially it leads to the formation of a ketone. When ketone reacts with one more mole of methyl magnesium bromide, it will form a tertiary alcohol. So this molecule is achiral. Yes, it is possible. So this is achiral. This is giving achiral compound. And second one is, that is phenyl acetyl chloride. So this is said to be phenyl acetyl chloride, and this molecule is reacting with methyl magnesium bromide. So initially it attacks here, the Cl minus will be leaving, and it leads to the formation of a ketone. When the ketone is reacting with one more mole of methyl magnesium bromide, and you are going to get the tertiary alcohol, and this tertiary alcohol is also an achiral molecule. Third option, cyclohexanone. When it is reacting with methyl magnesium bromide, so this is attacking here, and it also leads to the formation of a achiral compound. So this option is correct. Next one is butanone. So say for example butanone means, so you can look at this one. Butanone, when it is reacting with methyl magnesium bromide, it will give achiral product. Yes, correct. Ethyl propionate. Yes, this is also ethyl propionate. This is also giving achiral compound. Cyclohexanone also will give achiral compound. Yeah, this is also correct one. Next, if you happen to look at this next option, that is ethyl phenyl ketone, just leave it. 3,4 epoxy ketone. Just before we have discussed here. So 3,4 epoxy, that is hexane, will give you a chiral product. So this is ruled out. So the right answer is option B and C. You need to work out for all the cases. So that is why this question is little tough. Next question, the reaction that yields cyclic product are, okay, so that is hexene, 2-hexene. One, two, three, four, five, six. Yeah. So now this molecule is reacting with CS2, I2, zinc copper couple. So this is an example of Siemens-Smith reaction. So this reaction involves cyclopropanation of alkane. So you are going to get a cyclic compound. So this will give a cyclic product. Next reaction is, that is 2-butanone with ethyl 2-chloropropionate. Yeah. Ethyl 2-chloropropionate. Yeah. So this is said to be ethyl 2-chloropropionate. So when these two molecules are reacting here, in the presence of sodium ethoxide, so there is a formation of an epoxide. What happens here? The acidic hydrogen will be generated, will be removed, and it will form an carbanion intermediate. And if it is attacking here, and the electron will shift over here, and this electron will again come back and it attacks the carbon atom, Cl will be leaving. So it leads to the formation of an epoxide. So this reaction is called as Darzens epoxidation. Just say it's a Darson reaction. Next reaction is that is hexane 2,5 diol. So totally it's 6 carbon, second position ketone and fifth position is ketone, having ketone. And when it is reacting with ammonia, it leads to the formation of a pyrrole. And this reaction is called as Paul-Knorr synthesis. In both cases, the formation of cyclic product is taking place. Right, so A, B, C is correct. The last one is cyclohexane 1,2-diol is reacting with sodium periodate. So what happens here? The CC single bond cleavage will take place and it leads to the formation of a dialdehyde compound. So in this case, acyclic compound is formed. So this is not the right answer. So right answer are A, B, C are correct. Next one is, this is a general statement type of question, and the correct statement among the following are, that is, in natural nucleic acid, nucleosides are linked through phosphodiester bonds. Yes, it is correct. The natural nucleic acid having sulfur containing heterogeneous base. No, it is nitrogen containing heterogeneous base. It is wrong. So isoelectric point of arginine is higher than that of isoleucine. Yes, this is correct statement. The molecular weight of guanine is higher than that of cytosine. Yes, this is also a correct statement. So A, C, D is correct in this question. And this question is involving NMR signals. You need to find the number of NMR, proton NMR peaks for the given molecule. Yeah, so these two methyl groups, if it is a simple alkene, means these two methyl groups are diastereotopic in nature, but this is an alkene compound, so these two are enantiotopic. So these are enantiotopic methyl groups. So that means they will not give separate peak, they will give single peak only. So these two will combine together, it will give single peak. So this alkene part of hydrogen will give second peak, and these two are same environment, so they will give third peak, and these two hydrogens are in same environment, that is meta position, so they will give next peak, fourth one, and this hydrogen is having para position, so this is in different environment, it will give the fifth peak. So that means you are going to get 5 peaks in the molecule. If it is an alkene system, then you will get 6 peak for the given molecule, because these two methyl groups are diastereotopic in nature. So diastereotopic protons can be identified by using proton NMR technique. So this is not the question that they have asked. They asked a question for alkenes. Next question. So number of stereoisomers possible for the given compound is. So you need to find out the chiral center. And if you ever look at this molecule, so the stereochemistry of these two hydrogens are already given. So you should not consider this as a chiral center. So this is a chiral center. This can be a chiral center. That means stereo center. These two can be considered as a stereo centers. So n value is 2. Number of stereo centers are 2. Now the formula for this type of molecule, this is a symmetrical molecule. If it is symmetrical molecule, the formula is 2 power n minus 2 power n by 2 minus 1. So this is a general formula for molecule is symmetrical, and if it is having even number of stereo center, you need to follow this formula. That is 2 power n, that means 2 power 2 minus 2 power 2 by 2 by 1. So that means this part will be 1. 1 minus 1, that is 0. So you are going to get 2 power 2 minus 2 power 0. Anything power 0, that is 1. So this is 4. 4 minus 1, you are going to get 3 isomers. So right answer is 3. This is the last question. Again, this is a simple question. You need to find out the number of chiral center present in the given molecule. And I'm starting from here. So this carbon having 4 different groups, that is a chiral center. This is also a chiral center. And here also there is a chiral center. Don't look at the first atom. You need to look at the entire part. So if you happen to look at the entire part, you are going to get a chiral center here. And there is a formation of chiral carbon here. Here also there can be a chiral carbon. So that means 1, 2, 3, 4, 5, and there is one more chiral center here. So there are 6 chiral carbon present in the given molecule. 1, 2, 3, 4, 5, and 6. Yeah. So the right answer is 6. That's all. I hope now you can come to a conclusion that the questions were really tough. Some questions were really easy, but most of the questions are really tough. And you can share this video to the people who are preparing for IIT JAM or GATE examination or even CSIR examination or TRB examination. And if you find the video is very much useful, you can like it. Share your feedback in the comment section, and do not forget to subscribe our channel. I will meet you all in the next interesting video. Until then, take care. Bye.